Hi, my name is Jingwen. Today I will introduce an important tool in electrical engineering, the multimeter. And the multimeter has two types of them. One is the analog multimeter, and the other one is the digital multimeter. So a multimeter or a multitester, we can also call it a volt-ohm meter. A multimeter is an electronic measuring instrument that can measure voltage, current, and resistance. So the first type of multimeter is the analog multimeter. And here is the picture of the analog multimeter. It is based on a microammeter whose pointer moves over a scale calibrated for all the different measurements. And it moves a needle along the scale. And the second type is the digital multimeter. Digital multimeter is more common nowadays. It can display the measurement as digits. In some way, I think a digital multimeter is more friendly for the beginner. When using analog multimeter, it is hard for beginners to read accurately. Both type of the multimeter has its own advantage. So when using as a voltmeter, it will be better to use a digital multimeter since its resistance is much higher. A digital multimeter is from 1 million ohm to 10 million ohm. So compared to the 200 kilo ohm for an analog multimeter on a similar range, on the other hand, it is easier to follow a slowly changing voltage by watching the needle on the analog display. So when using as an ammeter, an analog multimeter has very low resistance and is very sensitive, with scale down to 50 nanoamp. More expensive digital multimeter can equal or better this performance. So most modern multimeters are digital and traditional analog types are distinct and become absolute. And so when the resolution of analog multimeter is limited by the width of the scale pointer, which we can see in here. And so the accuracy of printing of scale, zero calibration, number of ranges, and error due to the non-horizontal using the mechanical display. Accuracy of reading obtained is also often compromised by miscounting division makings, error in metal arithmetic, parallax observation errors, and less than perfect eyesight. Mirrored scale and large meter movements are used to improve resolution. 2.5 to 3 digits equivalent resolution is usual. So when it comes to the resistance measurement in particular are of low precision due to the typical resistance measurement circuit which compress the scale heavily at the higher resistance value. Inexpensive analog meter may have only a single resistance scale, seriously restricting the range of precise measurement. Typically, an analog meter will have a panel adjustment to set the 0 ohms calibration of the meter to compensate for the varying voltage of the meter battery. And here's the brief history of multimeter. The history of multimeter is quite simple. It has 3 generations. The first current detecting device was the galvanometer. It was invented in 1820s. The second generation is the analog multimeter. But people soon find out that the analog multimeter is not quite accurate and it is hard to use. because the zero adjustment and the accurate reading from the instrument panel. So the modern multimeter we use right now is the digital multimeter, which is the most common type of multimeter now. And here's the some introduction of the internal design and mechanisms for analog multimeter. For analog multimeter, it consists of a moving coil analog meter with a switchable bridge receiver to allow it to measure AC signals. In this graph, we can see a set of rotary switches allow selection of various series and shunt resistors. This will make the instrument capable of measuring both voltage and current. And when using the digital multimeter, one of the key processes is to convert analog to digital. There has many forms of analog to digital converter, but most widely used in digital multimeter is ADCs. DMMs is known as the successful approximation register, or SAR. Some SAR ADCs may only have resolution level of 12 bits, or possibly more dependent upon the application. Typically for DMS, resolution level is 6 bits with speed of 100K samples per second. This level of speed are more than accurate for most DMM application, where high levels of speed are not normally required. Typically, for most bench or general test instrument, measurement only need to be taken at a maximum rate of a few a second, possible 10 a second. So here's the basic introduction of both analog and digital, of analog multimeter and digital multimeter. Thank you.